In this video, we will learn about jet engines and the engineering behind them. A turbofan engine is what powers modern airplanes, and it works by spinning a large fan in front of it. The fan pushes air, and the faster it rotates, the more air it pushes. This results in a thrust which moves the plane forward. So why can't we use a motor to spin the fan? To just keep it simple. In fact, just like in electric cars, a motor and a battery combo would be more efficient than a jet engine. So why do we need a gas turbine engine? It turns out the answer lies in something called as energy density, which is nothing but the energy per kg of fuel. Jet engines use liquid fuel like kerosene, and the amount of energy in 1 kg of kerosene is about 40 times the amount of energy in 1 kg of lithium batteries. So in short, you will need more batteries, which makes it impractical. In fact, I did some rough math, and when the energy density reaches say about 1000 watt hour per kg, an electric airplane might actually be viable. Not large ones, we're talking about two-seater airplanes that are really small and actually travel very less frequently between 2 points that are very close to each other. Now that we can move this out of the way, let's go back to how a jet engine works, and let's take a simple example, a microturbine. A microturbine is a small jet engine, and the way it works is by taking air, compressing it, and sending it inside a combustion chamber where it mixes with fuel and burns. The energy from the combustion spins the turbine, which in turn spins the fan and the compressor at the front. So once the system starts, it just continues as long as you have fuel. In other words, to get more power, you need to burn more fuel, for which you need more air. Given that the space is constant, more air in the same space means a higher pressure, and this is exactly the primary concept around which this entire thing is designed. You need to figure out a way to get higher pressure in the same space, and that's where a multi-stage compressor is used. This is done using a twin spool design. A twin spool design has two concentric shafts that can spin at different speeds, a low pressure shaft and a high pressure shaft. The low pressure shaft contains the low pressure compressor and the low pressure turbine. The high pressure shaft contains the high pressure compressor and high pressure turbine. Across the two stages, the pressure ratio can be as high as 40. With reference to atmospheric pressure, that's a pressure of 40 bar, and that's quite high. At this point, some of you might be wondering, how did the shafts start to spin? A jet engine uses an air starter powered by compressed air, which rotates the shaft to a reasonable extent, after which the engine can self-sustain because of combustion. There is a neat centrifugal clutch mechanism which detaches the air starter from the engine by disengaging at high speeds. Overall, I think it is a pretty cool device. Now, if you are interested, here is a list of things that engineers work towards optimizing in different stages of the entire operation. Alright, I hope you enjoyed this video, and I'll see you in the next one.